Okay, Year 11, it's less than 24 hours until GCSE Physics Paper 2, so what are you doing right now? Hi, I'm Dr. De Bruin. I'm a GCSE and A-level science teacher, and I also make revision videos on YouTube. You've hopefully had a chance to watch my whole paper summary, and now you're ready for some advice about silly mistakes that students make on Physics Paper 2 and how you're going to avoid them. In the spring's required practical, you calculate extension by subtracting the initial length of the spring. If you do this correctly, your data will be directly proportional, which means as force doubles, extension doubles. This will make a straight line graph that passes through the origin, 0, 0. That relationship will hold until you exceed the limit of proportionality. At that point, if you have force on the x-axis, then your graph will kick up, and if you have extension on the x-axis, then it will kick to the right. Newton's first law confuses people because they think that if forces are balanced, then an object should be stationary, which isn't true. If you're on your bike and you increase the forward force by pedalling harder, you're going to accelerate. And if you increase the reverse force by braking, then you're going to slow down, not go backwards. So if the forces are balanced, then you continue to move at a constant velocity. Distance time and velocity time graphs look a lot like each other, so make sure you're paying close attention to the y-axis and know which one you're dealing with. If you're asked to define stopping distance, braking distance, thinking distance, make sure you're doing it in terms of distance, not time or braking force. And remember that braking distance will be increased by wet weather or icy weather, and by poor brake condition or tyre condition. Just saying the weather or the condition of the car isn't enough for a mark, you need to be specific. If you're labelling wavelength, then go peak to peak or trough to trough. Don't go in the middle, people always get it wrong. And remember that amplitude is only half the height of the wave. In the ripple tank required practical, you can measure the wavelength by putting your ruler next to the ripple tank and taking a photograph. You can improve the precision by measuring the length of, say, 10 waves and then dividing by 10. Even though an oscilloscope will display it as a transverse wave, sound is actually a longitudinal wave. Listen to the EM Spectrum song one more time. Radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, gamma rays. When a wave refracts, it suddenly changes direction as it moves into a medium with a different density. When light goes into a glass block, it will bend towards the normal, and when it comes out, it'll bend away from the normal. Speaking of that normal, make sure you're measuring the angle of incidence between the normal and the ray. Your magnetic metals are iron, cobalt, and nickel. Any conductor carrying a current has a magnetic field of its own. By looping a wire into a spiral, we can make a solenoid, and by adding an iron core, we can make an electromagnet. You can increase the strength of that electromagnet by adding more coils or by increasing the current. And then we could test the strength of it by seeing how many paper clips we could pick up. You can predict the motor effect using Fleming's left-hand rule. Your first finger stands for the magnetic field, your second finger stands for the current, and your thumb stands for the force or the direction of movement. The field goes north to south, and the current goes from positive to negative. Remember, it's conventional current, which is weird. It's not the way that electrons actually travel. If you're trying to make a motor, you're going to need a split ring commutator. Finally, double check your calculator, make sure it's in the right mode. We want degrees, not radians, and no standard form or anything weird like that. Good luck, Year 11, you've got this.